Well, cheers. Welcome to my backyard. This is my house in Bristol, and I've had time to lay out all my telescopes, all 6 of them. Here I am. This is Roland. That's me. And as you can see, all my telescopes behind me, and my wife who made me the lovely juice, which I thoroughly recommend, a nice bit of nutrition or something to drink before a nice long clear night outside. So this is how I go about planning my evening. First I get my tablet out, put on some planetarium software. The green horizon you can see here is, that's the horizon. The yellow is the ecliptic, the yellow line, and the sun, as you can see, is about to set. It's on its way down. This is Venus near the Pleiades here, and I might have a go at looking at that. So if we follow the ecliptic to the other side of the sky, we see the moon is about to rise. It's below the horizon at the moment, but certainly going to make its way above in not too far in the future, in a few minutes. And these 3 planets are for early bird, early in the morning. If somebody's still up, they can look at Mars, Jupiter, and Saturn. So, what sort of things will I be looking at? Well, not tonight, but lately I have been looking at the Whirlpool Galaxy M51. Now I don't see it like that through my backyard telescopes, because this picture was taken by a telescope in orbit around the Earth. So that's not what anybody sees from Earth, no matter what size of telescope they have. So this is the Whirlpool Galaxy, not far from Ursa Major, in Canes Venatici. And actually the sort of thing I do is drawing. I'm not an astrophotographer, so here's my drawing of M51, the Whirlpool Galaxy. This is straight from my notebook. I mark down the date, the seeing, various bits of data, what equipment I'm using, the time, and so forth, and do little drawings. Here's the page a little bit clearer, this particular entry. Let's have a look at a few other pages. You see a few other things. A globular cluster, a nice big one, M5, looks, which is very similar to M13, the great globular cluster in Hercules. And we'll have a look at my drawing of M13. Not like me to get it wrong, but there you go. 110 Messier numbers, easily done. So that would be in Hercules, and through binoculars, when I look for M13, I look for these 2 sort of guiding stars each side of it that I'm pointing at here. Here we go. Here we can see the 2 stars, and M13 is definitely non-stellar. It's a faint fuzzy through binoculars, and it's quite spectacular because it's the largest globular cluster in the northern hemisphere. So here's Jupiter, and the 4 Galilean moons. We can observe them, and we can see that they encircle the planet, just as Galileo saw and deduced that they do indeed go round Jupiter, and therefore he deduced perhaps the Earth therefore goes round the Sun. But we can verify this as amateur astronomers, and it's quite exciting to do so. The Dumbbell Nebula, a planetary nebula, quite a good one in the summer months. The Ring Nebula, top left, I've got my finger on a star called Gaia, followed by some long number, because that's how it's catalogued, and it's quite a faint star, and I use it to test my equipment out, whether I can see it or not in one telescope or with one eyepiece and so forth. So there's always plenty to do. Other drawings, we have more clusters, globular clusters, a sighting of the ISS the time, etc. When it appeared, the magnitude. I estimate the magnitude. I think I've written -3 there, which Venus is -4.4 at the moment. It's extremely bright. So not quite as bright as Venus, but getting there. One night must have been cloudy, and all I saw was a fox. And that happens. And here are more drawings, and we're getting on to Mars 2 years ago was in opposition a little low from the UK. I happen to be in Greece, but in these years the opposition, every 2 years you see Mars is in a favourable sort of close opposition, it's called, to the Earth. So there we go. And also this year in 2020, Mars is going to be quite good and higher in the sky to observe. So watch out for Mars in late summer. All the notes that I need about my equipment are in here. Anything that will help me in the future. And now we're on to eyepieces. So these are very, very high-end eyepieces. Teleview. This is a Teleview 14mm radian, medium power. This one is a low power eyepiece, something that I would start off with, especially to locate an object before I move up to higher power. And so what I'm showing now is how I've entered all the major eyepieces and telescopes that I have into Sky Safari. That's the software I use on my tablet, and binoculars and finder scopes, so that I can see the exact field of view that I will be getting. So I've selected 2 fields of views, and the first one, this one, is what I would see through my Celestron NextStar 6 with a 24, the eyepiece I just showed you. And the outer circle is what I would see through my binoculars, 10x50s. I've just flipped the screen there, if you've noticed. Because that's what SCTs, that's how they see the sky. And it looks like I'm in the constellation of Triangulum at the moment. And if you notice, the binoculars may just about fit that constellation in. So that's, usually I find it quite accurate. Not 100%, but very useful to know. This is an 8.8mm eyepiece with a wide field of view, which is a very nice one. And this is not quite in the same category as Teleview, but it's also a bit close to the 14mm, this 12mm one. But a nice eyepiece nevertheless. These are quite old. They only have about 45-degree field of view, so they're kind of a little bit sort of narrow, but good long eye relief. This is my Teleview star diagonal, 90-degree, and it's a dielectric one. That means that light transmission is very, very good indeed. You get 10% more brightness, let's say, than a normal star diagonal. And the Newtonian telescopes don't actually need a star diagonal, but the SCTs do. And you need a 45-degree star diagonal if you want to view something, a terrestrial object, to write the image. But I've just shown you another 90-degree one. A simple moon filter by Mead. Don't get the plastic Celestron ones, they're very frustrating. The moon can be extremely bright, so you need a filter, a grey filter. This is a very sort of budget eyepiece that's good to put in your pocket if you're going away on holiday and need something to take up a small amount of space. I recommend this. It was impressive for the price, because Teleview eyepieces cost 10 times this. But that's just the nature of good equipment, and I do recommend good equipment. good eyepieces, good equipment. Some of the equipment I have is very sort of entry level. Some of that I have. I'll show you a telescope that costs less than £100, an 82-degree field of view. There we go. Always nice to have some star atlases. I have the Cambridge one. I have a couple of others, but this one's nice and small. I like the layout. It's good. Obviously, I have the planetarium software, Sky Safari, on the laptop, which is great. Now, this, I would definitely recommend this book if you're starting out, you've got a telescope and you want to know what to point it at. It's a great book for a sort of manual that should come with all telescopes. Sort of once you've set it up, what do I look at? Well, that's when you need this book over here. And I actually like the drawings in it and the layout. And it's a very popular book that's in its 5th edition now. Perhaps there's another one out. This is the Backyard Astronomer's Guide. So pretty much in theme with this clip that I'm doing here, all about telescope mounts, all about the celestial sphere, our place in the galaxy, in the universe, the big picture, and with an emphasis on the practical side of astronomy and a bit of astrophotography. This guide is definitely 1 step up or 2 step ups from Left Turn at Orion. A lot more detail in here. You need probably larger scopes, darker sights to see some of the things suggested here. But I like the descriptions. I like the narrative. I like the layout, the tours, etc. Perhaps 1 or 2 glossy photos too many, but it does a good job. It's a collection of articles from Sky and Telescope magazine, I believe. So definitely, yes, 100 tours for the Backyard Telescope. Definitely a very nice book. So next stage, let's get on to part 2. Is I think I'm going to take a look at some telescopes now. There's the first one. This is quite a small 4-inch. That's the diameter of the primary mirror. Now, it is a parabolic mirror, and this scope is less than £100. So one mustn't expect too much from it, but it does actually work. And this is altogether different. This is a Maksutov, which we'll have a closer look at. We'll look at the telescopes outside now. Yes, they are covered up because I don't want them to cool down too quickly. One must always sort of pace things and time things so that the temperature of the scopes is about right. You can have problems with dew and all sorts of things. So anyway, this little mount here is a nice little portable mount. And I've got my C5, Celestron C5 mounted on it, and it's simply on a photographic tripod. So it not perfectly stable, but it does settle down, and it's good enough, and it's something that's portable, and you might be able to sort of pack away and take away on holiday. This is my my largest telescope. Not my most powerful telescope. It's actually perhaps the least powerful. Focal length is 1,200 millimeters. But the aperture is 10 inches of the primary mirror, which is what you see at the end there, where I'm reflected in the primary mirror. That's 10 inches across and will gather a lot of light. So it's good for deep sky objects, and not so good for high-powered or high magnification, because the 2 types of telescope are high-powered or high light gathering. And I have, and in the middle you would have, for example, Schmidt-Cassegrains, and I have all 3 categories. I have 2 of each, and I have one 8-inch SCT at my sister's house in Sardinia. Well, right now we're looking at the polar aligning scope within the mount. So this mount can be polar aligned, This is a cheap Chinese mount, but it's functional. It's actually a copy of the mount that's on this telescope, or it might be the other OMC 140. No, this mount is an Explore Scientific Twilight 2. This has got a 2-inch back. Now this is a very powerful telescope because it has 2,000 millimeters of focal length, meaning I can reach high magnifications. The aperture is a lot smaller, 5.5 inches compared to the Newtonian. So you would use this scope for planetary spotting or for splitting double stars, but not so much for deep sky objects, for the fuzzy deep sky objects. Here's the mount. It's a very simple mount. You don't need counterweights. It's quick to set up, and it's generally very good. Quite heavy, about 7 kilos for this mount, but quite stable, and it's totally manual gears, and you orient yourself manually. This is the other OMC, Matsukov by Orion Optics. It's a 5.5-inch mirror. This is the finder scope on it, a 90-degree finder scope, and this one has a 1.25-inch back for smaller eyepieces. I don't actually have any 2-inch eyepieces. That's the counterweight, and this mount is a better mount. It's a Japanese, it's the original one, very nice and smooth. This is the small one that was on the sofa before, the 4-inch reflector that costs less than £100. It's simply on a photographic tripod, but it does come with its own mount, which is probably actually better, sort of tabletop mount, and the finder on it. Very cheap, nasty bit of equipment, but you can actually get it to work. This is my Celestron Nexstar 6 SE, probably my favorite telescope. And for many years, I resisted the idea of a go-to telescope. And this one's got a handset. It can find many objects in the sky, but eventually I gave in and I power it with this. It looks like a torch, but it's actually a battery that needs charging every 2 or 3 months. And it's actually far easier than putting batteries in the little battery compartment, which I do with the other mount. This is a laser collimator now, so I'm going to give a go at collimating my Newtonian. So collimating is sort of angling the mirrors, positioning them so that they line up very accurately. And some people think the laser collimation process is not accurate enough. And that may well be true, but I quite like it, and it's probably better than nothing at all. So if that dot's in the center, you're all lined up, but I'm very, very slightly off center here. These are the screws that I use to position the primary mirror, to nudge it and to angle it slightly so that the laser is aligned, so all the optical surfaces are aligned. It's 2 mirrors in it. Now it's bang on in the center. This is another laser collimator I have, and I get slightly different results. I don't know if they sit in the tube completely accurately. But this is the inside of the tube, and here I'm actually adjusting the secondary mirror. So as the laser fires in from the focuser, which comes from above the screen, I'm just making sure that it's centered on the primary. Then, depending on how the primary is set up, it will then go back to the collimator, and you'll see the red dot in the center or not. So then you have to collimate the primary. Okay, so this is the very small, the very lightweight, small go-to portable mount, which is my latest piece of equipment, and I'm very impressed with it. I control it with a tablet with an app. This is a photographic tripod, And that's my sort of portable setup. Back to the 10-inch telescope here. We've talked about polar aligning it. That's pointing at Polaris at the moment. And yes, I'm talking about the fact that this is the original Vixen Great Polaris mount, and the white one is a cheap Chinese copy of it, and it's not quite as smooth. The gears don't quite turn as smoothly, but it works. Here I'm locking an axis because then I can use the worm controls to actually engage the gear and move the telescope slowly. And here we go. And that's how you operate this telescope. You track the stars manually. As the Earth rotates, the stars rise in the east, set in the west, as does the sun. And you must follow them with this worm control here. So as you can see, I'm trying to line up the telescope because I'm trying to align the finder scope. So I'm using the corner of next door's roof. And in my finder scope, I've put a little needle into it at some stage. I can't remember exactly doing it, but I think that was my doing. And I'm just trying to line them up and focus things here. I've got the 45-degree diagonal here, so it will appear upright. So just checking the finder scope again, because good to align these things. The finder scope must be aligned to the main optical tube so that we can find things. And here we've got it pointing at the corner of the roof, and this is in the big telescope, the image. You could almost see an ant crawling about on that. Well, you definitely can if they are crawling about there. I've seen little insects there. So that's a simple alignment I do before the sky even gets dark. And, well, it has to be done with any telescope, really. And it saves a lot of time. But of course, the go-to scopes, once you've aligned to the first two stars, you don't really need to use it because the telescope will go to your object without any problem. Another detail on the roof, the sky window, the skylight window. Same procedure a few times. It's actually very hard to get the camera into the eyepiece to film this, but I know I had a go. And since I don't do astrophotography, there aren't many ways I can put sort of images across, actually. So that looks all aligned and ready to go for the evening. Here they all are, waiting for we've got a nice clear sky, nice and blue, which is just what we want. Unfortunately, the moon's going to be very bright, and but anyway, we can perhaps observe the moon later on. Here's the OMC, Matsukov, the powerful telescope. Here's the C5, a 5-inch SCT Schmidt-Cassegrain. Here's the 4-inch Newtonian, which fits into a backpack. I took it with me to Greece last year. Here's the 6-inch SCT Schmidt-Cassegrain. Very nice telescope, excellent, highly recommended. Here's the very powerful OMC 140. You see I have two of these tubes because one I bought second hand. And this is my big telescope, 10-inch Newtonian, all set up and ready to go for the night. So let's move on to part 3. Here I'm introducing you to part 3. We're about to actually look at something, the moon, Venus, a few things. And we're back to the C5. And it looks very small, but that is actually the moon. And back to the Skywatcher, portable go-to mount, about £200 sterling. Highly recommended, and it's controlled with an app. This is an Android tablet, the same one I think I showed you before, and you can see it's tracking the moon. And here we go. Well, the 6-inch runs off a battery, not a battery, a power pack, a big battery, let's say. And this mount, I have to put 8 little AA batteries, and that's pretty fiddly actually. But it does make for quite a compact little unit, and they'll run all night. They don't seem to, but then I'll have to recharge them and so forth, take them in, take them out. But this can be run off a big battery. I just need to check the specs and see that I've got the right fitting for it. That little wire is, I'm just showing you how to fit it all in. So you have to fit things in. They're very snug, and it takes a bit of fiddling about. So I've turned it on, and it creates a Wi-Fi, generates its own Wi-Fi field. You then connect to that with your tablet, to that Wi-Fi signal, and Bob's your uncle, ready to go. Right, here we go. Here's the moon. And I do believe that's Venus. If you can see it on the screen, I don't know if it got picked up. It's getting a bit darker here. Same telescope, the C5. And actually Venus was, some people say it's a disappointment. You just see what phase it's in, which is about half at the moment. And I wasn't actually able to get a good picture of Venus because, again, just getting the tablet, the little camera down the eyepiece is next to impossible. So I think I'm going to show you the moon again. And this is the app that controls that mount. You can align, usually you would align things, and then you can search for a planet, a star, a deep sky object in the database, and it all works brilliantly well. And here it's tracking to Venus, as it says. Go to Venus, and has 11, 10, 9. There's a little, tells you how close it is. You can see Venus here, and this is the red dot finder, as it's called. That's what a red dot finder looks like. But here's the moon again, because Venus didn't quite come out as expected. That's the terminator, where you see the light and dark on the craters. Terminators. Well, that's it. Cheerio from me.